Welcome! As promised, today we're going to talk about graphing absolute value functions. I think this is so exciting to be able to visualize what is going on here when we look at the distance something is from zero. So, gave away our first blank. So, recall the absolute value of a number is defined as its distance from zero. We have been studying up until this point linear functions, but now we're going to look at graphing the absolute value function. Recall that the parent function, right, the most boring version, no transformations or anything, of the absolute value function family, right? A family is just a group of functions with similar characteristics, is f of x is equal to the absolute value of x, right? Nothing crazy has happened. All I've done is taken the absolute value of my inputs. I haven't done anything else. So while the graph of a linear function is a straight line, just spend a lot of time solving and graphing and writing linear equations, so it should be pretty familiar. The absolute value function graph is going to be V-shaped. This V-shaped curve is like having positive and negative linear function branches. So I'll show you what I mean. Like a V, right, is made of like a negative slope like this, and then a positive slope like this. Ta-da! Okay. The vertex, which is going to be this right here of the graph, is the point where the graph changes direction. So it goes from negative to positive, or positive to negative in terms of the slope, or you can think of it like increasing to decreasing, or vice versa. All right, so I'm going to teach you how to graph this parent function here using a table. So I have chosen -2, -1, 0, 1, and 2 because 0, 0 here is going to be, actually, let me change what color I'm using for that. 0, 0 here at this point is going to be the vertex of our parent function, where it's going to change from decreasing side to the increasing side. And so this will give us 2 points to the left and 2 points to the right, so we can get a good symmetric view of that V-shaped curve. So this table should make sense, right? If I plug -2 into my function, just the absolute value of -2, that's going to pop out +2. Plug in -1, that's going to pop out +1, and so forth. And then I'll just connect my points here, like so. And that is the parent function. All right, so go ahead and look at your graphs here. Or the explore portion. I want you to predict how this graph of g of x, absolute value of x plus 4, will be different than what we just plotted, and how h of x is equal to absolute value of x minus 6, all within the absolute value, is going to be different in the graph of f. So go ahead and try to make some predictions there, what you think is going to happen. And then you can complete these tables by plugging the x values I've chosen into the functions, g of x and h of x, and then solve. Or like plug them in, evaluate, and plot. All right, so of course your answers are going to vary, but you probably said something like moves up 4 for this one, And perhaps you said something like moves right 6 for this one. So the technical terms for those, right, is that this was a vertical shift, right, up 4. And this is a horizontal shift, right 6. So if we fill in these tables, we're going to get out 6, 5, 4, 5, 6. Seeing that same symmetry that we noticed in the parent function popping up here. This will look like 2, 1, 0, 1, 2. We're going to plot those points. I'm going to zoom in on my graph here. Alrighty, so this first one looks like this. Notice it's like it has a branch with the slope of -1 and a branch with the slope of +1, right? And then for h of x, it's going to be over here. Its vertex was at 6, 0. And again, kind of those -1 slope branch and +1 slope branch. Okay. Okie dokie. All right, and so now we can flip to the back. And you're going to do the same thing where you're going to graph the parent function, and you're going to graph a q or a p of x and a q of x. You're going to tell me how you think those might be different. Well, you're going to tell me how you think they're going to be different. Then graph them, and then we'll see what's going on. All right, so let me just get my parent function up and running here. We are on a time crunch because I can see that my baby's starting to wake up on the monitor. Okay, so there's the parent function. All right, so in predicting how you think this guy here is going to vary, probably said something like he's going to be 4 times as tall, but we'll say, we're going to call this has been a vertical stretch. By 4. And what it does is it's like increasing the slope by 4. Or, yeah, well, 4 times. So instead of having a slope of 1 or -1 on the left-hand side, it's going to look like it has a slope of -4 and a slope of +4. So if I fill out the table for this one, it'll look like 8, 4, 0, 4, 8. And so plug that in. See, this one looks much narrower or steeper, depending on how you want to think of it. And this guy here has 2 things going on. So this has been through an x-axis, what's called an x-axis reflection, and a vertical shrink by 1/2. And if those aren't the terms that you use, that's okay, right? This is the first time we are experiencing this vocabulary, and we'll talk all about it in just a minute. at that bottom section that says transformations and functions. So my y coordinates for this guy are going to be -1, -1/2, 0, -1/2, and -1. And so if I go to graph this, all three of these still have that vertex at 0 because they didn't move up, down, or left or right at all. But then we're going to be at -1/2 and -1, like so. So this one appears wider, right? So notice I'm saying things like wider and narrower, not like fatter and skinnier, because we are body positive about our graphs here, people. All right. So now we're going to talk about transformations of functions. So this is one of my this is where I get really nerdy. This is one of my absolute favorite things about math, because how every function, this function transforms the absolute value, the things that this a value does, and the h and the k are gonna be the same way that quadratic functions transform, the cubic functions transform, the radical functions transform, the log functions transform, the exponential functions transform, the trig functions transform, like things that you don't even know exist yet. And it's just so cool. And I love that about math, the patterns that go on here. All right, so get off my soapbox for a second. Let's talk about our friend A here. So A, okay, if we're going to bring absolute value back into business here, if the absolute value of A is greater than 1, right? So we're thinking like, usually it's a whole number, not like a fraction, but it could be. So we're thinking like it could be 3/2, right? But usually it's like 1, or not 1, usually it's like 2, 3, 4, something like that. There's a vertical stretch by whatever this a value is. So the one we saw was 4. If, however, the absolute value of a is less than 1, so between 0 and 1, there's a vertical shrink by a. And so this is the one where you saw above that had the 1/2, right? Where it was 1/2 as tall. All of our y values got multiplied by 1/2. And then if the a value is negative, that means there's been an x-axis reflection, right? It negated all of the y values. Next, we're going to talk about h here. Friend h. If h is greater than 0, positive, right? That means that this guy is going right h units. Now it's going to say x minus h is the default, right? So if h is a positive number, like say +5, it'll say x minus 5. That means right 5 units. If h is less than 0, that would appear as, say, if it were -5, x plus -5, it's backwards in here with the x's because of inverse operations that we'll see later on. But this will go left h units. And so the way that I have to think about this is this shifts the graph h horizontally. And then for k shifts the graph. My algebra teacher used to spell this incorrectly on purpose. Verticality, because k. All right, cool. So if k is positive, we're going up k units, and if k is negative, we're going down k units. All right, that was a lot for one lesson, but we got to visualize for the first time transformations of functions, which is my favorite, and I'm so excited to be able to keep on this journey with you guys. Bye.